record. I'm going to share my screen. And I'm going to, oops. Oh yeah, I thought I was going to be late, but because I thought I had to take my mom to the dentist, but no, I was back in time. I'm also trying this new thing on PowerPoint, and that's that it's going to do closed captioning, and we'll see if it's just annoying or whether it's actually pretty good. So what I'm going to talk today is about the dark side of the cloud. So I'm going to talk about the AI offerings, but I'm also going to talk about what to think about when you look at these things, because there's downsides, there's good sides, there's bad sides. So what can you get from the cloud platform? So all of the public cloud platforms offer all sorts of different services, what they call AI services, at what looks like fairly affordable prices compared for you developing an AI platform. And so with this, they look at images, speech, translation, machine learning, all sorts of different things. So what I want to do is I want to look at a few of the offerings. There's a whole bunch more that I don't have time to cover everything. You can go and look at them yourself. But I want to just survey a few of the offerings, and I want to look at the downside. So one of the amazing things is, and this sort of makes you wonder, is that when you go to any of the publicity material, I'm going to focus on AWS and Azure, but you know what? It's on all of them. One of the things that they are proud of is that no machine learning skills are required to use any of their offerings. The problem with this is that it also gives you the idea maybe you don't need to understand anything about machine learning to use these offerings. And that is a danger, and we'll see why. So what are the different AI services? They have image understanding, speech recognition, natural language understanding to a bit. These are attractive, these offerings that they have, because they're easy to use, they're fast to use, so you can get something up and running very quickly. As they state, you don't need any expertise. And that means that you don't have to train the models. You don't have to train the machine learning models, and you don't need the data sets. And most of these data sets are huge that you usually need to train these models. Now, they're selling this as a green option. And there's some truth to this. Every time somebody in a machine learning course gives out an assignment and has everybody do deep learning or TensorFlow or any sort of things like that, thousands of trees die all over the planet, because this uses a huge amount of energy and basically is contributing to climate change. There's some astonishing figures that some people have calculated as to how much courses in AI have contributed to climate change. And it is true to a certain extent, because people train models over and over again, and it takes a lot of time and energy to do. So isn't this a good thing? You can go and use their already trained models, and you would think, I mean, they have some experts there, so wouldn't this be better? Now, this is their philosophy. So I'm looking at the AWS one, but you know what? It's the same for all of them. They really have the same thing. So their idea is that you have ready-made AI programs, right, that you can just fit in as part of the workflow in your application. And so they made it so that you can customize your work using their, what they call deep learning technologies. And so they're promoting this as saying, well, this is stuff that they use for their own work at either Amazon or Microsoft or Google. And so why not take advantage of their machine learning experience and use their already trained models? Now, this makes a lot of sense, because obviously these companies do use lots of different models and training sets and everything. Like, they can gather all the training sets, they can train all the models, they have the powerful computers to do this, excuse me, they have the personnel to do this, so they can train up all these models. So why shouldn't you take advantage of it and use it? Well, what we're going to look at, as well as looking at what they provide, we're going to actually see there's some severe limitations in, and this, to be fair, this is not just for what's provided on the cloud. These limitations are for all machine learning techniques. The only thing that I want to point out is that because they're selling this as you don't have to understand what's going on, you can treat these as a black box, you may not realize what kind of shortcomings these services have. And because you're not doing the training and you're not providing the testing data for most of these, you don't really know if what you're getting is biased in some way. And so there's been studies that have found that there's lots of bias in these models, gender, racial, class, there's all sorts of different biases that come from actually the people who are developing the systems. The AI systems are as good as the training data is as good as what people think is necessary for training. And we'll find out, people don't think too hard about this. Accuracy, they will tell you how accurate their models are, as in saying they're really good. But there's very few published studies of how accurate their models are, the ones that they're selling you. And this is because it would be very hard to test this. But when people have taken the time to test it, they found that these models aren't all that they're cracked up to be, that there are obvious deficiencies. Now, that's not to say they're not useful. They are useful, but you have to understand what the deficiencies are. So the first thing I want to look at is not tuna, but image analysis and understanding. Even though cats do like tuna, my cat proved that last night. But what I want to do is I want to first start with this comparison. Now, just a warning, this may be aging as we speak because all of the services are obviously being added. All the platforms are adding services, but this just gives you, I wanted to put this in because it just gives you an overview of some of the image analysis programs that are out there, the systems that are out there that the different platforms provide. And they do provide slightly different things. So it's not that they're all the same. Some specialize, some have things that others don't. Usually they're little niche things that they do, like food recognition is something that IBM does. Yeah, and you know, they have, you know, like silly things like celebrity recognition, you know, all these different types of things that are out there. And most of the platforms will provide that. So you have to, you know, like you can stick with one platform and look at what it provides, or you can shop around the various platforms. So the one that I'm just going to look at, because it's very similar to the other ones, is Amazon's Rekognition image software. And this does image and video analysis. Almost all of these things will sell you on the fact they're using deep learning. They don't actually tell you anything more than that. But what their systems are trained to do are detect objects, recognize various things in scenes. There's an emphasis on faces. They can extract data or logos. Some of them recognize some celebrities. Searching for and comparing faces is a big application. With this, with some services like the Amazon one, they will return a confidence score for everything that they identify. And excuse me, most of the services also, like the Amazon one, will put bounding boxes around anything they detect, like faces. And what Amazon is telling you that you're getting when you use this service is that you're using the deep learning technology that Amazon has developed, and it's done this analyzing billions of images that they get from Prime Photos. So what can it do? So if you give it images, it can do things like this, labeling. So it'll say, here's a person, here's a rock, here's a mountain bike. Excuse me. Oh, I don't know why I'm coughing so much. Anyways, and beside it are the percentages, and this is their certainty, or what they think is the probability that they're right. So they're showing you how certain they are. They're really certain it's a person, really certain it's a mountain bike. They can also do labeling. So in this, you'll see that it's recognized golden retrievers, and it's found them in the images, although I think there's a couple of other ones in there. But anyways, It will extract various things. You can ask it to find your company logo in social media or things like that. It can do all sorts of things, and it can do this in images or in video. Like I said, face detection, huge application. Even though there's ethical issues with doing this, but they're letting you detect faces, and then they can give you various attributes of the face. So in this case, it's female, the eyes are open, she's happy and smiling. And so, they claim they'll give you attributes such as gender, age range, eyes open, glasses, facial hair, all of these different things. You'll notice they're very good here about not mentioning the one thing that has actually defeated some of the facial recognition systems, and that is race. They are very good at actually ignoring that because some of the systems have had huge problems with that, especially the Google system. But we're going to discuss why that's the case a little bit later on. So they do this face search. So once again, you see the bounding boxes, and they also say that if you want to, you can give them a collection of faces. Let's say you want to find your friends in your photos, you want to find yourself in your photos, and so you can give them those, and then they will compare it as after they found the face. So most of these same features will apply to video. And so here, this is a comparison of the video analysis APIs that are available from Amazon, Microsoft, and Google. Like I said, this might be out of date now. They constantly add, but you can see that there's some distinctions between them. With the Amazon recognition video, you get, once again, deep learning. Everything's deep learning. It can detect various activities, recognize, they can track people through their movements in a video. One of the things they're selling it on is to be able to look at inappropriate content. And you can do all of this on material you've stored in Amazon S3. The results that they give you obviously are timestamped, so you can find it back in the video. They can do bounding boxes around various things, and you can also hook this up to their live stream, their Kinesis video streams, to detect various things like people or activities. So you can do something like this where you can follow paths of a person, so they're identifying various people, or at least tracking various people. They might just be person one. Later on, you might say person one is, Lionel Messi or whatever. But what it's doing is you can then use this, let's say, in an application where you're going to have analysis of how well one player did in the game, how much they ran, where they were in the field, that sort of thing. Azure also has very similar things. So they have what they call their computer vision service. So they will identify and tag visual features, object detection. They also they can identify commercial brands. And they do things where they have various categories. So they have a category taxonomy where they'll recognize various things and categorize an entire image into one of these categories. The other thing that actually I think Microsoft does a little bit more and maybe better than AWS is it likes to provide a human readable description of an image. So this is very interesting, that if you can take images, you can analyze them, you can come up with a description in language, then they're searchable. So this is actually an interesting application, so that you could take images and then you could search on them based on the description from the image analysis API. And Azure has specialized in this a little bit more than I'd say the other two have. They can do all sorts of things, like even identifying image types or color schemes. They have various domain-specific content where you can look at images. So all of these services have a lot of really attractive features where you can take your images and you can do all sorts of analysis on them, or your video, and do this analysis. But there are some difficulties, and I'm going to start with the some of the imaging, but this applies to all of the different AI or machine learning applications that they've put up on their systems. So one of the problems is that they do things very well, but they're limited, and they don't often tell you what the limitations are, and they don't tell you very much information about how they're doing it. Therefore, you can't figure out what the limitations are on your own. So what could be so bad? So I said this to another class. I said, try to find the information about the algorithms they use in these various programs. And I know I had one person who was dedicated to trying to prove me wrong, that you couldn't find papers written about this. And actually, he thought he'd found them, but he really didn't. They were talking about something related, but not the actual algorithms, or indeed the data sets that they use. So they may say they use deep learning. Well, that doesn't mean anything. I mean, deep learning is a big category of artificial neural networks. You need to know a lot more than that to figure out exactly what they were doing. You also, more importantly, need to know the data sets that were used to train the neural net systems. Now, the thing is, there is a big upside of not having to train things yourself. One, most of these deep learning systems need thousands or millions, usually millions of images or data points to actually be able to train very well. Now, the thing is that that's expensive to collect yourself. Most of these companies have some other way, through some other division, to get these images. They own some companies that have images for some reason. So, you know, imaging services or video services. So why not take advantage of the fact that they have all this data? But if you try to learn to like go out and try to find papers or books or anything that explains to you exactly what they're doing in detail, you will not find it. They really want to sell this as a black box solution. Now, they also offer, and I'm not going to go through all of these, but they do offer services so that you can run machine learning algorithms on your own data. The thing is, they cost a lot more because it takes a lot of horsepower to run these algorithms. And therefore, you can do it. They will offer you all the software. They will offer you the VMs. They will do all that sort of thing. And you can do it on your own. The thing is that for the most part, most people don't have the expertise, nor the time, nor the money to do these things. So they sell you one. Why don't you look at what they have? So and before I forget, I want to get the chat up in case people have questions. Okay, so let me go to what has been found out about this. So there's a very good book that will actually give you a really good idea about actually checking for bias in data or in machine learning. And it's called Invisible Women. And it's really looking at things that you don't think are a problem. And it doesn't just look at imaging, but it looks at a lot of different things. But one thing it does look at is imaging. So the data sets that they use to train these models are flawed in that there is a gender data gap. So in a 2017 analysis of two very commonly used data sets, and these had over 100,000 images from the internet, and they found that the images of men greatly outnumbered the images of women. And you might think, well, that's not a problem. But it is. If you understand how these algorithms work, they're not magic, they're math. And actually, they're not so much math as they are statistics. And so if you have a bias or a data set that has more of one category than the other, then you may have issues. So in a paper, and on the next slide, it'll have the name of the paper. They studied data and models that are associated with multi-label object classification. And with this, then it was going to be semantically labeled. So in other words, you'd have an image, it would find something in the image, some object, it would classify it and would give it a label. Okay, so in other words, you would look at that and say, oh, that image contained a dog and a person, and they were going for a walk. Something like that. So they found that data sets for these tasks had significant gender bias, and that the models that were trained on these data sets, so in other words, when they train the deep learning models on those data sets, it amplified the bias. So for example, cooking is the images that they used to get these this activity classification out. The cooking is over 33% more likely to involve females than males in the training set. And when they looked at the model itself, it amplified this disparity to 68% at test time. So in other words, it was very biased to say that if there were females, it was more than likely to correctly identify them cooking as opposed to males. And the paper was called "Men Also Like Shopping," because what they found was it wasn't just like that there was less, there was more women in one category and less men. There was less men in some categories and more women. There was like all sorts of different combinations, so that if you had a binary classification task, so you wanted to say, was that a man or a woman? So it's one or the other in this, so binary task, or something saying, is that cooking or not? If you had unbalanced labels, so that means that the samples in the majority class dominate the data set, then when you train a classifier to optimize its accuracy, it's going to predict the majority label more of the time. So it's mistakes. All models make mistakes. That's not a problem. All models make mistakes. They can't be perfect. But in this case, you know what type of mistake they're going to make. They're going to neglect the minority class. And so for a lot of things in the world, when they do these studies, they find out that the minority class are women because they don't have as much in the data set about women as they should. The other thing that they find is that they also don't have enough about racialized groups. And so that's where you get the big problem with the Google face recognition system that was identifying Black people as gorillas. And that was because they didn't have very many Black faces in their facial recognition training sets. And so if it didn't see it, it couldn't predict it, or it saw it, but it was so small a sample that it didn't really learn it. And remember, if I said to you, do you want 95 in this course or do you want 60 in the course? You're going to choose 95. Well, these models are that smart. If most of the time it's their prediction is white male, that's the prediction it's going to make. If you know the majority of the samples are white male, that's what it's going to say. And so that if you do search for images, and you can find lots of them, I thought it was funny that when I did ask for images, you can find images, all sorts of images of men cooking or men shopping, this very fashionable fellow shopping. And in fact, that person was in an article, this picture, it came from an article where they were saying they actually found that men shop more than women, and they actually spend more when they shop than women do. So there's a lot of bias that's actually not because it's real. It's not because they actually surveyed what's out there and found out that there was an issue. It's actually false in that it's people's biased judgments that are, and the people are the people who are developing these algorithms. Now, there's also something else that's actually really much more, this was something I didn't think of when I was thinking about human bias, the idea that the data sets themselves were, the classes were unbalanced. That struck me as being very obvious, because that's a really traditional error in machine learning and artificial intelligence. Very, 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 very common. See this all the time. But the other thing was, when you're giving labels to images, they have to train on something. And so what they do is they get humans to annotate the images. So you have to have a training set. So you've got to have these labeled images, and who labels them? Well, it's human. But there's a problem. When humans annotate, they often will exhibit human reporting bias. In other words, they will put things in to their annotations that aren't really exhibited by the image. So if you look at an image, they will say, oh, there's something in that image. They will annotate it, but they're using their own prejudice and preconceived notions to put that in, not unbiasedly, clinically telling you what's in the image. And there's another paper about this that is interesting about stereotyping and bias in a Flickr dataset. So Flickr is I don't know if it's still around. You put your photos and you stored it. And so they used this data set. And what they did was they crowdsourced descriptions of the images. Right? And the assumption that they made was that when they went out and crowdsourced these descriptions, because they wanted a training set, that people would actually focus only on information that could be obtained from the image alone. In other words, they wouldn't be biased by their own preconceived notions or their own preconceived biases. And what the paper found was that there was evidence against this assumption. And they provided a whole list of different biases and unwarranted inferences that could be found in this set. So this is one of the problems that you have with crowdsourcing. So people will wax eloquently about how wonderful crowdsourcing is in like the Wikipedia world, or things like labeling images and all those sorts of things. But the fact is, people aren't perfect by any means with these tasks. And what they actually reveal is that they have biases, and a lot of them, they're unconscious biases that they're going to put in, even though they're given instructions, just put what's in the, just annotate what's in the image. That's not what they understand. So when they looked at this, they looked at various linguistic bias that got into tagging. So there was a whole bunch of these. I'm only going to give you a few, but there was a lot of them in there. One was adjectives. So this was the use of sexist language or racist language that you would get into. Let's say if you were tagging a picture that had a picture of a doctor, they might say it was like a female doctor or a Black doctor. And it's like, a doctor's a doctor. It's like, why are you labeling them that they're female? Why don't you, does anybody say it's a male doctor? They might say male nurse because their expectation is a nurse is female, but that's actually showing a bias. So it's either sexist or it's racist or something. And it's, I'm not saying in the sense that these people are like, Ku Klux Klan members or, raving misogynists. But the thing is that they're expressing a cultural norm because they're seeing something that's inconsistent with something that's traditional. And someone mentioned this is what happened with Amazon's automatic hiring AI. Exactly. This was because, and this happens all the time. And actually, they try to get an AI to do hiring. And the fact is that the one problem with hiring is that people try to find people that are like themselves. It's like, if I've seen this many times when I've been on hiring committees, everybody's looking for a mini me. It's like everything in their judgment has to be like me. Well, the thing is, when you encode that, what they found when they were encoding was that most of the people working in tech are white males, young white males. And that's exactly what it was biased for, because they didn't realize in a way that they are not the only thing in society. So they really put those, maybe unconscious, maybe conscious prejudices into their work. The other thing can be people use negation. So they would say, oh, the garbage man wasn't stupid. And it's like, well, did you expect a garbage man to be stupid? Why would you say that, right? So you have things that are revealed in language. That's what the study found, that when you went and analyzed the language people used in tagging, that they revealed a lot about themselves and about their culture and their society. And so the statements about the images went way beyond what the visual data alone was showing. And so it was based on additional assumptions about the world that came from cultural assumptions. It came from personal biases, and they could be anything. It could be ethnicity, it could be relationships, it could be status or occupation, all of these things. The article is very interesting because there's so many things that they found that people were so biased about in actually putting these labels on. So just as an example, I have two pictures here. So one of them are two, it was tagged, okay, this image was tagged as two young men on the beach. In the other one, it was tagged as a couple on the beach. Now, actually, I know that the one that was the couple on the beach, those are actually models. It was an advertising picture for, I don't know, some surfwear or something like that. But they said a couple. So in other words, they're actually putting this heterosexual label on the fact that there's a man and a woman. Actually, I think it's kind of freaky if they think that couples dress alike. That's really freaky. But the thing is that they're saying they could be brother and sister. Right? They kind of look alike. They could be brother and sister. And okay, it's freaky that a brother and sister would dress alike, but still. The thing is that they made an assumption by saying couple, and they didn't make that assumption about the two young men on the beach, right? They didn't say a couple on the beach. They could be. There's nothing wrong with them being branded as a couple, but that actually showed that the person who labeled that did not think of that. Right? That wasn't the first thing that came to their mind, that was a couple. And in fact, we don't know, maybe they would have thought that that was unacceptable to them of saying that that's a couple, but they made these assumptions. And so just their language, so even though we think as human beings that we're producing the gold standard that machine learning should be trained to, in other words, we want the machine to mimic us, they actually are mimicking us, but in a bad way. Because what they do is they actually learn all the bad things. And what's really amazing is I heard this, I was listening to a show on the radio, and it was talking about technology, and they were, maybe it was Quirks and Quarks or something like that, but they were interviewing this graduate student, and they were talking about this work to, and I think it was to recognize music. And so, and he actually, without any shame at all, said that he got his information by just going around and talking to all of the people that were in the lab. And when we mean people, he means young graduate students, probably in the lab, probably male, probably white, probably from an entitled class. I mean, probably from a certain socioeconomic class. And was saying that this basically portrayed everybody's experience of music. And it was like, whoa, that's so not correct. And the thing is that it wasn't like he even noticed this. And it wasn't like the interviewer noticed this, because they were all of the one group. And so you had this group think, and it's very dangerous. And the problem is that when you use these services from the cloud platforms, you have no way of knowing if there's any bias in any of these things. And so it's sort of buyer beware. They have some very good properties because they are a much cheaper way of doing it. It is much better for the environment if we all use correctly trained models to do this and didn't recreate everything all the time. But is that what you're getting? So I'm going to now switch to, this was looking at images. And what I'm going to do now is that I'm going to get, oh, where did I put it? Okay, I'm going to get the next one, which is going to be about, let me start the slideshow, is about speech. So we looked at the imaging. So one of the other things that is a big item on the cloud platforms are looking at speech applications. And to a certain extent, these might even be something that you would use even more than necessarily the imaging ones, because images are quite costly. So here's once again a comparison of the various speech and text processing APIs that are out there. And there's a whole bunch of different things for language recognition, topic extraction, spell checking, autocompletion, all sorts of things that you can get as applications, APIs that you can attach to your own application. So they do have speech to text, and this is when I use this captioning application in PowerPoint. This is a similar sort of thing in that you're taking text, speech, pardon me, and making it into text. So Amazon Transcribe, once again, uses deep learning. They love selling this, and they do this automatic speech recognition. And so they're selling this as you can use this to transcribe user service calls, do what we're doing right now, closed captioning, subtitling, and generate metadata for media assets. These are all very good things to be able to do. And they've got some things to do it with. Something else that they have, which is very expensive, is their Transcribe Medical. And this is to do medical speech to text for clinical documentation. And so what this does is it's capturing audio, and it will respond with a series of JSON blobs that have the transcribed text, and they do some various timestamping, punctuation, all sorts of things, and they save it to an S3 bucket. So for the transcription, the just sort of general one that you can get, it's called real-time transcription. You can go play with it because you can, if you go to that site, they have an example where you can start recording and it will test it out. I'm not going to do it live here because there's often a problem with internet lag, and actually I'm seeing that there's a problem right now with the internet because I'm getting the transcription timing out sometimes because of the speed of the internet. But you know, it's interesting to go through and see how good it is. They do claim that they've tested it on different accents or different types of people, that sort of thing, and it's not too bad. So it's something to play with and see if you could use this. Azure has the same sort of thing. They do speech to text conversion for a variety of different sources. They have different models that they claim will overcome various speech recognition barriers. Such as different, you know, unique vocabularies, and that's what, like the medical one, where you're going to have all sorts of nice clinical and medical terms being used, different styles of speaking, and of course there's background noise, because if this is going to be taking it from an environment, there's usually going to be that. And they of course use deep learning because everything does. But there are problems, and it comes down to the same sorts of things that we're talking before. Can you find out exactly how these things work? And can you find the documentation about how well it works and on all different categories of problems? Well, with Google's speech recognition, there's actually been a study. And that study found that there was a significant gender bias in the speech recognition. And so on average, for each female speaker, less than half, or 47% of her words were captioned correctly. The average male speaker was captioned correctly 60% of the time. And so that's actually, you know, like if you look at those, you know, that graph, it's there's a problem with the amount of bias that this is revealing. But you think, well, is this really a problem? You know, like really the difference between men and women? And in fact, you might be surprised that actually there's a difference. But to be honest, there's a long history of this in speech recognition. So if you've worked in speech recognition or any of those technologies, this is not a problem with the cloud platforms. This is a problem with how the speech algorithms and training have been done. So one of the things that's really funny is that some of the people that have had their systems tested and a bias has been found, then actually blame the group that's not doing so well, which is in this case, in this study, women, and say that, oh, well, it's because it's harder to recognize women's voices. Unfortunately, that isn't the case. And actually, that's been known for a long time. And in fact, it's very funny because in early fighter aircraft where there were systems talking to the pilots, the voices were female voices because of all the noise in the cockpits. women, they knew women's voices were easier to detect and easier to listen to for content. And so women's voices do tend to be more intelligible, mostly because they're at higher frequencies. That's one of the issues. So if you don't have high frequency hearing loss, then you hear women's voices actually better than you hear men's. Women tend to talk slightly more slowly than men do. They also favor more standard forms, and they also produce longer vowels. And that makes it distinctive much more than men. So the thing is, and these are all on average, obviously everybody's voice is slightly different, but the fact is there's no reason, if they do the study on actual voices about how people hear voices, how voices are captured, all those sorts of things, there shouldn't be a problem with women's voices. But there are problems for the systems. So why? Why are there problems? Well, the problem is, once again, unbalanced training sets. So if you look at all the popular ones, and these go back for decades. I remember when I was a graduate student, Timmit was the most popular speech corpus going. And that was like decades ago, and it still is. And it's over 69% male. So remember, if all it's hearing are male voices, or the majority are male voices, it's going to learn more about male voices. VoxForge is the same. It has major gender and per speaker duration imbalances. So in other words, it's not a balanced training set. There is one corpus, the British National Corpus, is sex balanced. They actually have made sure it was. But that being said, most corpora don't publish their demographics, and cloud voice services do not tell you which ones they use. So in other words, so if you go and say, okay, I want to figure out if I'm going to use Google or Azure or AWS and use their voice services, I'm going to look at which training sets that they use so I can make that determination. If there's known biases in the training set, no, you can't, because they don't tell you which ones they use. And with some of them, even if you found out which ones they use, you don't know if they're biased or not. There's very few. Like I said, British National Corpus is one of the few that actually has looked at the composition of their training sets so that they actually publish the balance in their set. So you might say, okay, so what? So it's a little bit harder with women using these systems. Well, there's a problem. There are voice controlled things in cars or airplanes or whatever, or trains, where an operator is using their voice. And if the system is not understanding them the first time, or is making mistakes, even though they might eventually understand them, that's distracting. If you have to, constantly be making sure that you speak really slowly or whatever, because it tends not to recognize your voice. What's even worse is with the medical systems. If there are higher transcription error rates for women than men, that's a problem, because then it's not doing the same job for women as it is for men, and this could create a dangerous situation. And so this is not something that's trivial. If something does not work as well for one group, and we're just concentrating here on men and women, that's not to say that, there aren't other imbalances that are there. And these imbalances make it harder for that group. So these are usually groups that have other issues that are making things harder for them in their jobs or their careers or in society. And these automated machine language systems don't make it better. And the thing is, I'm not saying that things have to be perfect. That would obviously not be something that we should be, saying that these are terrible for. But the problem is that you can't get enough data or information from these systems on the cloud to know which ones you should pick and why. And so they don't tell you this. And so this is something that if you're integrating it into your own system, now you have a problem, because there's one part of the system that you can't analyze. You can't analyze how good that part is. Therefore, you have to trust it. And there's lots of evidence that you shouldn't trust it. Now, I want to end with just one more thing that they have. And this is, let me, no. Where do I want to go? I want to go to slideshow. Okay. And this is looking at something that you might think actually should be pretty straightforward. And that's text processing, because it's pretty, you would think, much easier than image or speech. If we look at Amazon, they have a service called Comprehend. And this uses, once again, machine learning to look at text. And so they have these advanced text analytics and document analysis where you can identify the language of a text, extract key phrases, names, brands, events, evaluate sentiment. You know, is this a happy thing? Is this a bad, you know, like, is it sad or whatever? So you can figure out how negative or positive things are. This was made famous by people first looking at how to analyze reviews of movies. So did the reviewer actually like the movie, or were they negative about the movie? And this has actually formed the whole basis for a lot of sentiment research, because it's difficult. You might think it would be easy, but it's not. And this also will analyze your text. It'll tokenize it, find parts of speech, those sorts of things. They also have a medical one, which will extract medical information from unstructured text. And this is important because there are still a lot of written notes that doctors do. So they're the voice one, because doctors love to dictate everything. But if they don't dictate it, then they will just write some unstructured text. So most medical records are a combination of those two. And so this is actually an important area. Can you actually analyze the unstructured text? And so you can go, they have real-time analysis, so you can figure out, you can input your text. And so this is great. So you can go there, input your text, and get a view of what it's going to be like when you send text into the API. And so you can use various analysis types. One is a built-in one where you use all of their stuff. You can customize it. You can put things in, and you do have to customize it. And I'm going to show you, just as an example, if you go to theirs and you put in, if you look at their example, it's very modern, very sort of, what should I call it? Sort of commercial text. It's sort of businessy. It's very businessy. So it's really looking at what their main market is, which is going to be business users. And if you look at it, it's not too bad. But I wanted to break it because I like doing that. So what I did is I put in this text, and I grabbed some text because I'm working on a project in the digital humanities, and they're looking at 19th and 20th century female British writers. And so they have all sorts of information about this. So I just grabbed some text that was in the system, which was about the Brontes. So I thought, well, I'm going to put this in because this is nice, because it'll test the system, because it's got information that's not businessy, that talks about fiction as well as reality, and it's got a lot of terms in it that are not as common now as they once were. So I put this text in, and it's just chatter about their early childhood, where they went to school and tons of people died at their schools. And so then they had to come home, and then they were homeschooled, and they had some of the things that it talked about, some of the books that they were homeschooled with, so that you would get an idea of how they were schooled. And that was the text. So if you look at the results, so in this, you've got entities, key phrases, language, sentiment, and syntax. So if we go to the next one, which is very similar, I don't know why both of them are the same, but anyways, I think I have a duplicate slide. But if we look at this, it'll have entities. So this is going through and it's picking off all the single-ish words or some phrases, things that they think would go together. And then they try to categorize it. And it's not doing too bad. So we've got, you know, Charlotte is a person, and it's got the confidence level there. So it's not too bad. Lowood School, organization. Well, that's usually how these things are done, that would be classified as an organization. So everything like of the pink ones, like Lowood School, the Clergy Daughters School, you know, these are organizations. That's right. You know, and then it's got like Jane Eyre. Oh, sorry, someone's trying to annoy me by calling me. So let me get that off and shut them off. Okay, sorry, I forgot to shut my phone off. And then we've got all these people's names, and they're picking it up, and that's fine. And their confidence is great. So this is doing pretty well. So you think, well, this is not too bad. So even though it's, you know, about people that are in the you know, 19th century, it's not doing too badly. So if we go through, it's pretty good at picking up people. If we look at, we've got Blackwood and Edinburgh Magazine. They're saying their titles, well, Blackwood, sort of, but, and the magazine, yeah, it's a title, so it's not too bad. It's doing pretty good with all of this. But then if we go through and look at some of the things, we can actually see that we can fool it. So we've got where it picked out in entities, a new geographical and historical grammar, which was a book. And in one thing, it said it's identified it, but it doesn't necessarily identify it. It identifies it as some sort of title. It does that the same with a grammar of general geography. That's good, it's a title. But then if you follow along in this sentence, it talks about the lands of Angria and Gondal, and they're saying their locations. Well, sort of. Their locations, they're fictitious locations. But all it's doing is it's doing very preliminary entity analysis. If you looked at what the state of the art is in entity analysis, no, this isn't very good, because usually what you want to do after this is you want to know what the entity actually is. And yes, it's a location, but it's a fictitious location. But you know what? That's not too bad. It actually got that. If we look at the key phrases, once again, it's not too bad, except actually the really funny thing is if you look at some of the phrases, and if you look at something here with a punctuation mark, it sort of gets captured by it, you know, as well. Okay, I'm being a little bit hard on it. It's not doing too bad. So, but here you have the error. And you know, it's putting it together. Is it a phrase? I don't know. But even if it's not bad, but it's captured the punctuation. So it needs a bit of cleanup. Sentiment. It says it's sort of neutral with 99% confidence. It's talking about people having to be homeschooled because everybody's dying. I'm not quite sure if that's neutral. The fact that there was no negative connotation to this is a little bit strange. If we look at syntax and we go through, this is the surprising part, because we can actually find some errors here. So if we look at it, most of this seems, it's okay. Doesn't look bad. You know, it seems like it's pretty good, except, okay, it makes some trivial things where it's picking out the apostrophe S for that, which is, you know, like that's kind of silly, but it's okay. But this is the thing that's the interesting part of this. There was a name of a textbook, including it, which was entitled A New Geographical and Historical Grammar. And if you look at it, it's taken all those words out and it's given them parts of speech. Okay, they're all wrong because it's in a title. And even though the system was able to recognize in another part of the system that this was a title, it didn't do that when it came to analyzing the parts of speech. What's even funnier is if I go, and it's, you know, like it found the punctuation part, that was fine. And though, so it should have understood it before. If we do this every time we get capital letters in there. So a grammar of general geography, any of the titles, or the other one, a new and geographical and historical grammar, they have these weirdnesses about the nouns, about proper nouns and things like that because of the capitalization. And then I went in and I thought, why not? I'll just take the capitals out. And all of a sudden now it changes, right? So this was really sloppy. They didn't really actually go through and combine things that they already knew to figure out how to analyze parts of speech in a title. And so it's kind of strange that they couldn't do this. So part of the problem is that while this is not bad, it's certainly nowhere close to state of the art, which makes you wonder a bit about which algorithms they're actually using, because it's actually not that good. So they do have other things like this Textract, where they can extract various text from documents and forms. And once again, it's based on deep learning. It's always learning from new data. And so this is what they show you if you go to their site to say, analyze a document, and they give you this form. And it, it shows how it went through that form and it picked out all sorts of things. And it does a really good job, right? And, I thought, well, okay, it can go through and do all of that. So I'll give it a piece of text. So I just cut something out of a book and just gave it to them. So I thought, why not? It says it can do this. And so I asked it to analyze the document, and it doesn't do too bad, except when you start looking at, it had no way to realize about something that was a superscript, which was actually showing that there was a reference or some sort of footnote to that. And so those numbers got directly translated. So if you looked at the output that it gave you, you could see these numbers all over the place. And in fact, I don't know why the 29 got put in there twice. It shouldn't have. But the fact was that it was not too bad in being able to read this text. This is something I took out of a book, cut and pasted out of a book, but it couldn't, it didn't know enough about what text looked like to actually figure out anything that was unusual. Even worse, I'm really nasty to it. I gave it a table, and I wasn't that nasty. I really actually had a need for having that table and like put into a form where I could put it into using the analysis, so I could find like what each line was in this table to pull that out. So I mean, that's a fairly complex table. And that was a PDF I had, I wanted to get that table out. And when I put it through their system, it didn't like it at all. And it came back with something pretty darn useless. And it was no better than a service that I had sent it to, one of those internet services where you can give it the page and it'll come back with the table figured out for you. To be honest, it didn't do anything better than that. And I actually could get it on the internet for free. And when it came back, it was producing this sort of thing from the AWS service. So was it good? No, it wasn't even state of the art. And so buyer beware on the text processing side, which you would think. Text processing has come a long way. There's lots of tools out there. You can get huge libraries for it in Python. You can get a lot of this done for free on the internet if you look at their advertising or whatever. There's lots of free services. It wasn't any better than that. Nice because there's an API that you can use, but not great. So just to let you know that you have to be really diligent at figuring out whether these things are actually useful. So there's translation services, there's all sorts of things. But once again, it's up to you as the user, as the buyer of all of this, to figure out how good it is. And it's kind of difficult to do, and they don't help you. There's not a lot of documentation about the testing, about how they trained it, how it works. So, it could be better. So let me just get out of here. I'm going to stop the sharing. So I just wanted to give you an overview of what that looks like there, because there's lots of stuff and you're going to look at it and you're going to, at first you look at it and say, oh my God, this stuff is wonderful. And then you start using it. And it's not for free. So I just want you to be a savvy client of these services, because there's lots of, and it's not just cloud, but all of these types of services, but cloud's out there promoting this and making it easy for you to use this. And it is good in certain circumstances. So that's all I wanted to say about that. It's basically, make sure you investigate exactly what those software systems are giving you on the cloud.